Hello everyone and welcome back to Technically Unsure, where I'm not really sure what I'm doing technically.
I know what I'm doing.
Today we are going to dive into a product from a company called Forlinks. From what I gather, this company is based out of China and seems like they design like circuit boards, SBCs, SOMs. They create add-ons for SoCs and things of that sort. So in this particular video, we are going to talk about Forlinks OKMX9352-C single board computer, SBC. So if you're into AI at the edge, industrial grade reliability and next gen connectivity, definitely watch this video, and we are going to cover all the features of this board. At the heart of this SBC there is the NXP, and you know from the other previous video I did on the industrial computers from Debix. So NXP is building like industrial SoCs and CPUs, SoCs, and these are usually does have a very much wider range of the ideal temperatures, and also they have longer life, right? So if you buy NXP processors today, you are kind of like guaranteed to have the same thing for like 10, 20, 15, 20 years, right? So the NXP in this SBC is NXP i.MX9352. It's dual core Cortex A55 running at 1.5 gigahertz paired with the Cortex M33 microcontroller. It's a powerhouse for AI. It does have 0.5 tops for AI stuff, and it's powerful, especially for AI. And as I said, it's industrial, right? So this one, I think that the board that they sent it to me, yeah, by the way, full disclosure, just they sent the board. No control over the content and what I'm going to do, but they just sent the board and they have no control over what I'm going to do basically. So it's in terms of specs, I think from what I gather, what they ship is a gigabyte LPDDR4 RAM and 8 gigabyte of eMMC. And there's a dual gigabyte Ethernet port. This gigabyte Ethernet port supports time-sensitive networking, TSN, for ultra-low latency communication. Again, these are industrial stuff. There is Wi-Fi, CAN, FD, UART, and more. And from what I gather, the operating temperatures, as I said, it's going to be -40 up to 85 Celsius. So yeah, that's where the industrial stuff that I was talking about, right? And as I said, this one, you will have the same thing for 15 years. So NXP is like that. So if you are into industrial, again, automation, edge AI, this SBC is for you, definitely. And yeah, so before proceeding any further, let me just show you what they sent to me. This is the box that arrived. So let's open it together, okay? And yep, that's the board. I have been told that's going to be shipped, and this is plastic standoff stuff. I don't know where we can use that. I think that's for the board itself. I think that's a Wi-Fi antenna. Nothing else in the box. I like the box. It's very sturdy, and it was placed, the board was placed inside and very well protected, and the box was hard. So that's why, as you can see, everything is neat and it's untouched, undamaged. So let's open this up and see what we got. So here it is. I'm going to take away, and yes, this is for the 4 sides. If you don't want to put it on a metal surface, or you're worried about that, you can definitely put a stand so it doesn't touch anything on your desk or table. So this is the board, and they sent this power supply. Input is 100 to 240 volts, and it uses 0.7 amps, which is output is 12 volt to amp. So let's take a look at the I/O. This is the 12 volt DC input jack. So 12 volt jack in here, 2 buttons, and the Wi-Fi antenna, and this is 4G, and it came with the antenna already. Seems like soldered on. And yeah, so 12 volt, and this is reset button, on off button over here. This is the Wi-Fi, and I assume this is the Wi-Fi antenna. So this one goes like this, okay, and basically you can do it like that. And this is, it says right there 4G, and it came with the antenna. It looks like solder on, so you don't have to do anything, it just ships that way. And this is MIPI CSI. This is a USB port, and this USB 2. This one is the CAN that I was talking about. This is also can be used for RS485. So RS485, CAN 1, CAN 2, they're all in this. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pins in here. And in here in the middle, I see UART. So there is the UART, okay? And next to it, this one is LVDS, basically for this display. And what else I see here? This one is MIPI CSI and this is DSI. And this is LVDS. So these two are for basically connecting different types of displays. And here is the RTC battery. I'm gonna put something in here. I should have it. And then there is a key here, user key, user button, which you can program it. What else is here? Oh, there's also toggle buttons in here, which you can set probably mode of something, maybe programmable, maybe you can use it for changing something in the boot or whatever. So I have to check what this one is for. And this one is for boot actually, sorry. So these toggle buttons over here, as you can see, this is used for configuring the boot options. So we have to check, oh yeah, here is the boot option. So you see here it says S3 and here's the S3 boot right on the board, which I love. So in here it says OTG is on, off, and eMMC and SD card. So you have all the options over here. So that's S3, and S1 looks like it's for the LCD and LVDS. So yeah, this is for this display toggle stuff, and this is for boot stuff, okay? This is GPIO, and let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, so 28, I guess. So that's the 28 pin GPIO. Odd number, let's say, but it is what it is. I always say, who says like Raspberry Pi's 40 pin GPIO is the standard, right? So anyway, this 28 pin. And there is a debug USB over here, USB-C, and there's another USB-C port over here, okay? USB-C 1, USB-C 2, audio stuff in here, and another LCD connector over here, and then there's the SD card slot over here, and the 2 gigabit Ethernet that I was talking about. The SIM card slot is right here, and as I said, this is the 4G antenna for it if you want. And then there is this power toggle on off, okay? This is the Wi-Fi and Bluetooth chip. 4G module, you have to install it in here, okay? Antenna is right there, SIM card is right here, and you have to install a 4G module right here in order to use those, basically have 4G connectivity. On the back side, there's nothing, just the model, as you can see, OKMX91XXC or 93XXC, so yeah, 2 names, but yes, this is it. And the SoC, the NXP SoC is right under this, okay? We are going to check that, the power. So underneath this, there is NXP IMX9352. Okay, so that's pretty much it. Industrial board, and this is a development board, so you can use this for, you know, writing your own apps and testing it out, and using 4G, Bluetooth, Wi-Fi, and SIM card, 2 gigabit Ethernet, and the CAN 1, CAN 2 RS485. Okay. Oh, by the way, they shipped a USB-C cable, nice of them. So I'm gonna use what they shipped, and I'm gonna use the power supply they provided, so just in case. Yeah. So what I'm gonna do is I am going to connect wires to it. What I saw on their website, I think they provide an OS image, a Linux image. Obviously you can build your own, but I'm going to use what they provided and boot into it. There is obviously, as you can see, there is no output, display output. I mean, there is LVDS and MIPI DSI, but they didn't ship, and I don't have exact compatible display for this. So we are going to do SSH stuff. I'm going to SSH into it, do some benchmarks, test the GPIO, test the capabilities, and to check the documentation. I just want to see if everything is properly documented and I can use it. So give me a couple minutes. I will be right back.
2,000 years later.
All right, so everything is wired up. Basically, I brought out the power watt meter, whatever, and the Ethernet connection. That's it. So let's power it on. Okay, we got a bunch of LEDs turned on, as you can see, and the power consumption is very, very low. So that's like nothing. 3 watts, basically. 3.8, maybe goes up to 4. I didn't even see 4. So yeah, down to 3 watts. So what I'm gonna do is I am going to share my screen, and let's SSH into it. So SSH root 72.16.163, I think it was. Yes. Okay, so this automatically logs into the board. Obviously, you know, it doesn't have to have a lot of security features. This is like a development board and it ships like that. You can change the password. So let's see if there's anything in here. Where are we? Okay, we are in home root. That's unusual. Usually root is in /root, but anyway, we're here. I guess first let's see what's running on this. No grep, let's just see. Okay, so there's some Bluetooth agents running in here, and there's NTP server running on this. And what else is in there? Light HTTPD. Wait a second, what's that? Oh, something is running on port 80. Hold on, let me fire up Chrome. 172.16.163. Oh, does your system have an attached display device? Click OK and Remote Matrix will assume that a proper display device is attached to your system. Click cancel if you do not have it. Well, they didn't ship and I don't have a compatible. I don't want to connect something and maybe, you know, short something that I don't know. Maybe pins are different. I'm not going to connect the display that I don't know. And let's just say cancel. Okay, this is something. 4Links app launcher. But yeah, I assume none of these gonna properly work because I don't have the display connected. You can't run the GUI application terminal. The system detected your system is not connected to the display device. Okay. Oh, back goes all the way back. I guess this one goes up. Oh yeah. I'm curious where is this running from, but as you can see, there's audio recorder, RTC stuff, ping, watchdog, Wi-Fi, and 4G stuff. So light HTTPD, I think we can read the config file for it. So let's go to etc light HTTPD. Okay, that's long one. So let's grab root. Yeah, document root. Okay, that's an odd location. Nope, not that. Okay, let's go there. Oh, there you go. These are the PHP scripts right here. Execute command. Nano execute command. Oh, oh, look at that. It's literally just getting the command in the get parameter and executes it and shows you the output. That's like a PHP shell for you right there. Okay, let me try that. That's funny. Execute command.php. What was the argument? Command. Command equals, I guess, ID. Wow. There. Okay, so that's a PHP shell right there for you. So yeah, okay, let's see where it's running. Okay, so yeah, it's messed up because of the line breaks, but if you look at the source, there you go. Beautiful, isn't it? So we have a PHP shell right there. If you don't have SSH, you have this. That's an odd thing to have in here, but it is what it is. So yeah, just be aware, if you run this in your network, it's open, okay? Anyone can execute commands on this. Yeah, just be aware. But I assume this is just a SDK and a Linux that they ship it with for you to try. As I said, they have a SDK and a whole development build environment and a documentation where you can basically just go through that manual and documentation and build your own Linux. So you're not stuck with the Linux that they ship this with, okay? But I'm just showing you what is in there. Remember, I'm a cybersecurity guy, right? So I always try to look at things, even if it is not related to cybersecurity, with the cybersecurity eye, right? So that's why when I see PHP, when I see this, I immediately want to investigate the security, investigate how things are done in here, okay? So that's why I'm doing this. You also get familiar with this, you'll learn something hopefully, maybe. So yeah, always have that eye when I look at things, even if it is not related to cybersecurity. So anyway, so what else is there? Run script.php. Should we do a cat? Is it big? Let's see. Okay, let's do nano. Run script.php. Okay, so it is reporting errors, helper functions, get some parameters, get the submenu, gets the application from the app get argument variable, and then block less than stuff, and script link found up exec, and then it executes a command, execute command.sh, add slashes, random txt. Okay, so this one actually reads it from found app and looks like found app is get application or a function which uses the get app argument. So get application, I don't think it's in this file, is it? No, so it should be in the helper one. So what was the helper file name? Helper underline functions. Okay, it's here. So it gets the array and submenu and then the app name. So this is count if it is submenu apps, and then finds the app and returns the app. Not much going on really here. And what else is there? Read desktop file. File exists json.txt and is not 0. It reads it and returns it. Okay, so that's a static file though, json.txt. You can't make it read arbitrary files and spit it out. You can't really pass arguments to these functions unless the PHP is configured really bad. But anyway, so start caching and stuff. Okay, so yeah, there's a bunch of stuff. We already got command execution. I don't even know what I'm looking at, but yeah, there's a file. So cat json.txt. What's going on in there? There is some stuff in there that reads the sensor data and stuff. Oh yeah, these are the things like the icon for the RTC and ping. Yeah, we saw that there. The ping and RTC was right here. Yeah, ping and RTC. Okay, so U-boot, everything else is in here, so that's what it shows here. But I'm assuming if you connect an LDS or a display, it will, when you click on like terminal, it will show up in that display terminal. When you click on audio recorder, I assume something will pop up in that display. But yeah, as you can see here, it's 3-watt device, even when we are using it. So I'm thinking what we can do in here. Do we have iPerf 3? Oh, nice. Let me start my iPerf 3 server. Okay, let's do it. So iPerf 3, 50, bidirectional, 172.16.1.1. That's my edge firewall. There you go. Okay, 1.1 gigabit. That's true gigabit Ethernet. So that's okay. So that's good Ethernet. And the adder, let me just see. Yep, there's 2. So 1 and 2. I'm just using the 1. So yeah, it's okay. It's working. There's CAN 0 and CAN 1 and wireless network. So these things are working. Also, by the way, there. Let's see if there's any package manager. Okay, there is APT. And is there an issue here? NXP release distro Mickeldor. Okay, that's an odd name, all right. But apt update, it's already up to date. Okay, apt install, I guess stress-ng maybe. No, Sysbench. No, I don't think they have it, but I'm gonna try p7zip-full. No. Okay, that doesn't work. So we can't do release Sysbench. I can, I guess, download and compile if there's GCC. Oh yeah, what is the version? GCC. Okay, not too shabby. 12. How about make? There's also make. Okay, so that's good news. I guess wget as well. Yes. So what we can do is we can compile, I don't know, stress-ng or Sysbench. Let me see what I can do. All right, let's try this. Maybe I can install the binary version. Let's see. Oh yeah, there is dpkg. So if there is any dpkg release, no. Okay, so let's download the source code, which is this one. Copy link. Let's go to root folder. Let's see if it goes through. And also kind of as we are compiling it, we will know how fast it is based on the compilation. I don't have a base for how long it takes to compile Sysbench, but we are going to try. And let's see. Okay, configure. Let's see if we have all the libraries needed. If there are some missing, I don't even know if I can add it, but let's see. Okay, seems like the only missing one is MySQL library, which I really don't need. I guess I'm gonna try. So we have 2 cores in here. Okay, so I'm not gonna even bother, but 2. Oh, there's no makefile. So MySQL libraries is actually needed. I thought this is optional. Why MySQL? Anyway, so it seems like they're using MySQL on Debian systems. Is called this one. So let's see if we can. All right, so we are gonna move on. I'm gonna try stress-ng. Oh, just make? All right, so let this try. Okay, that took a while. Let's see if it runs. Okay, so let's start a basic stress-ng. Actually, it's 2 and method. Let's see how it goes. Okay, so it's over. Let's see what score we got. So 842. So obviously we are not going to compare this to Raspberry Pi, but yes, that's what we are getting, 842. Not too shabby, not too shabby. It's okay. My problem is, for now, I could not find any GPIO related stuff in it. So if you go and do like ls sys class GPI, as you can see, there is no GPIO stuff in here. So there's some samples and the documentation, but I couldn't really find how I can use these GPIO pins to turn on and off stuff. The documentation there is a little bit weak. I contacted the vendor for links. I will see what I can find on this, because yeah, without the documentation you can't really use these pins. So for the LVDS and display, they are selling their own module for LCD screen, so even if you don't have a compatible one, you can buy from them. Ethernet works. SIM card, I don't have the 4G module, so unfortunately I can test that, but you can see that device as well. CAN 0, CAN 1 is also there. So overall, looks like everything is working. We did compile StressNG, and APT is somehow working. We showed the Matrix application launcher thing that they have built. This is nice. I really didn't expect this to be on such a SBC. So although again there was that PHP thing that you can arbitrarily execute codes, but just demo app, you know, they have it in there. Overall, and also it's static on the 3 watts. It doesn't change. It's always on the 3 watts. So low power consumption. NXP is there. It lags a little bit on the documentation, but everything else that I showed you seems to be working. Yeah, I will contact the company regarding the GPIO. If I hear, I will share it about how you can do the GPIO and where the pins are. The documentation on their website doesn't really tell you how to do it. There are some just tables on what the purpose of each pin is, but there's no sysclass, you know, how you can connect and do turn on and off things basically with the GPIO. Anyway, let's pause it in here, and if I hear more, I will update you guys, but if not, for now, I hope you enjoyed this video. Looks like a neat board. We tested the most functionalities on it. Yeah, thanks for watching, I guess, and I will see you in the next video. Bye for now.